Okay, sorry, I think I was cut off there, but the surface area for this works out to be (216). Okay, so the surface area is equal to 216 centimeters squares. Now, it just happens that this volume is exactly the same. Now, it's just coincidence, but we take the 6 centimeter side length, we cube it, and we end up with 216, but in this case we have centimeter cubed. Okay. Okay, so the surface area and volume of a cylinder, okay, we should just go with the volume. That we'll start with the area. So it's going to be the circle, so pi times the radius squared. Since its diameter is 8, the radius is 4. And then we're going to give that area some height. Okay, so we end up with 4 squared times pi. That works out to be 192 pi, and that is centimeters cubed since we're talking about volume. To work out the surface area, we want to draw the net for this. Make sure you know the net. We know that these are going to be the pi r squared, so we get 16 pi here. Those are the circle areas, the two circles. We know the height is 12. We want the distance across, which is the circumference of the circle around here that makes up the rectangle. So that circumference is the diameter times pi, or 8 pi. So we get 8 times 12, or 96 pi. So then the surface area, just again make sure that you keep this organized, is going to be 96 pi plus 16 plus 16, or 128 pi, and this time it's going to be centimeters squared, okay, because we're talking about surface area. The decimal values for these again are 128 pi, works out to be approximately 402.12 centimeters squared. Okay, 192 pi works out to be 603 point. Okay, I need to move that. I'm going to move this picture over just a little bit. And just move this over here. Okay, so this is approximately equal to 603.19 centimeters cubed. Okay, approximately. I prefer you keep it in pi because pi's are exact. And again, please make sure that you're not just watching me do this. Do it, check it over with the video. Okay, so make sure you've done this first and then watch the video. So since we've got the surface area and volume, I'm going to work out the ratio. For this object, the surface area is 402.12 centimeters squared. The volume is 603.19 centimeters cubed. Okay, so I want to do this as a ratio. So we can leave it like that, but we really want to know the unit rate. Okay, the unit ratio. So we end up with 0.66. I'm going to round that to 67 centimeters squared to 1 centimeter cubed. Okay, so that's the ratio. We have this much surface for every cube that fits inside here. And again, some of these cubes are covered up, so we end up with surfaces that are not exposed. That's why we have such a low surface area to volume ratio. Okay, so if we double the diameter and the heights, what's going to happen? Well, if we double the diameter and the heights, okay, we're going to double the length. We're going to keep the same shape. So what's going to happen to the volume? Well, remember our little chart from before? Our linear length factor, okay, the length factor is 2. Okay, how does that affect the volume? Well, the volume increases by 2 cubed. Okay, so it increases by a factor of 2 cubed, or it increases by a factor of 8. The surface area, on the other hand, is area. So the surface area factor increases by a factor of 2 squared, or 4. So what's going to happen is we're going to get 8 times the volume, 4 times the surface area. So it's going to look like this. 0.67, this is actually 2/3. But we're going to multiply that surface area by our surface area factor of 4 times. We're going to multiply our volume factor by, so 1 cube, by our factor of 8 times. And then we're going to recalculate this. Okay, so essentially I'm going to times by 4, divide by 8. So I'm going to take that number, times by 4, divide by 8, or essentially divide by 2. And I'm going to get this new surface area to volume ratio of 0.33 centimeters squared for every 1 centimeter cubed. Now that's generally what we should expect. As objects get bigger, the more volume gets hidden inside the object, and we have less surface to be able to accommodate that volume. Okay, so that is our new surface area to volume ratio when we double the length, width, and heights.